Don't forget to put the date at the top of this. Let's talk more about quantitative data and specifically different types of graphs we can use. We talked last time about a two-way table. Today we're going to talk about a dot plot. So a dot plot is a plot of dots. It's exactly what it sounds like. So along the bottom, you're going to want to draw a nice long line. And we need all the numbers that are represented here. So everything from 1 to 18, it looks like. And try to make them evenly spaced, just like we talked about yesterday or last time, how we need to have good bin width. We also need to make sure these are evenly spaced. 9, I probably could have spread mine out a little bit more, but that's okay. Yeah, lots of extra space, that's all right. All right, and then a dot plot, you're going to put a dot on the top of each number as many times as it is represented. I think the easiest way to do this is to cross off as you go. So for example, I would cross off this 1, and then I would put a little dot down here above the 1. Cross off this one, and then another dot above the 1. Cross off the 10, a dot goes above the 10, so on and so forth. So go ahead and fill these in. Uh-oh. Y'all, I forgot about the 0. Better add in 0. Good thing I left myself some space. Alrighty. Okay, so the first question that I always am going to ask you when we're looking at a graph, what do you notice? So there's a couple of different things that you could notice about this graph. It's a little bit of an interesting graph. The next question that I'll ask you is, what do you wonder? Is there anything that maybe it sparks another question? You might want to go explore that question a little further. What else do you want to know? Is there more information that you would want to gather about this information here? So take a couple minutes and really think about that and think about the context. We're talking about number of goals scored by the U.S. women's soccer team in 2012. Just a quick side note, I did modify this data so that it fit with what I wanted. I used to use the real data, but it's not as fun as this data that I came up with. So it's technically not the actual data. But take a couple minutes, think about it, and answer this question. I'm going to put an answer box in here for you. So go ahead and share your thoughts in the answer box. Read the comments of your friends and kind of see what they're thinking about too. Okay, we probably need to look at this more deeply, okay, because there is a huge gap in the data here. I almost see 2 clusters. There's a cluster down here. There's a cluster here. There's this guy. Maybe he's an outlier. We'll talk about what an outlier is. He looks a little bit different. But I see this. Now, there's a little gap here, but there's a huge gap here from 5 to 9. So maybe there's a lead scorer who got injured halfway through the season. So maybe when the lead scorer was there, they were up here. And then when she got injured, maybe they were down here. Maybe they had, they played against really good teams and they played against really bad teams. And that would kind of depend on which clump they ended up in. But there's other information that I might want to find out because this graph looks really weird. Okay, so when we're looking at graphs, there is going to be things we need to look for. Okay? And there's a good acronym to help us remember that. So the goal of looking at graphs is you're basically looking for the overall pattern and things that look different from that pattern. So to describe a pattern, we want to describe its shape, its center, and its spread. Anything that doesn't fit that pattern is called an outlier, which falls outside the overall pattern. The acronym we're going to use is SUCS, SUCS. Okay, so for shape is the first S. And shape, we could have lots and lots and lots of things. So sometimes graphs look, oh, maybe they look kind of symmetrical. Maybe it looks like a bell curve. Maybe it looks like this. We call that right skewed. We'll talk about right skewed next video. Maybe it's left skewed. Maybe it's got a pattern that looks kind of like this, where most of the data is, my graph isn't as good as I wanted it to be, kind of uniform, okay, kind of centered all around the same area. There's lots of different shapes. Maybe it's a different shape than all of these. I don't know. I mean, you could just kind of think about, maybe it's got two peaks, which is kind of like the data we had on the last page. It had a kind of weird shape like that. The U stands for unusual features. There's lots of unusual features you could call out. Outliers are the big one. Sometimes you'll see this as SOCS, S-O-C-S, and the O stands for outlier, because outliers are the main thing we're going to talk about when we talk about unusual features. You also could talk about gaps in the data. We would want to mention the gap that we saw in the soccer data. You could talk about the two clusters we saw in the soccer data, or maybe there's multiple peaks. Right? Those are all things that would fall under unusual features. You want to talk about the center, the middle of the data. And you want to talk about spread. How far apart is the data? We will talk about unusual features, center, and spread later. The first thing we really are going to focus on these next couple days is shape, and then we'll talk about the other things as well. So actually, let's use our acronym here, and let's describe this dot plot below. So sometimes what I do when I am describing a graph is I just like to make a grid, and shape, center, spread, and unusual features, I like to put them all on there. You do need to write incomplete sentences when you're talking about the data. Okay, let's talk about the shape. What do you guys notice here? It looks kind of, I don't know, sometimes it helps me to go like this so that I can really see what I'm looking at. It looks a little bit bell curvy. Okay, if we had more data, I think it might fall into a true bell curve shape. We've only got 24 data points here, which is really not enough to see a true shape. But I mean, it looks a little bit symmetrical. So let's put fairly symmetrical. And for now, since we're just kind of still learning about these, I'm just going to list them. I think it'll be easier to do it that way. Okay, unusual features. Do we see any outliers? I'm noticing this guy over here. Even this one looks a little bit of an outlier. That one might be an outlier. We are going to have an actual formula for outliers. That will come later. So we think there are 3 potential outliers. If you mention that there's outliers, you don't need to mention the gap, because the reason you know they're outliers is because there's a gap. Okay. The center. Could we find, oh, how about the median? Do you remember that word from Algebra 2? Okay, actually, it's from 8th grade, so it's an 8th grade standard. I know you know what median is. It's probably been a while. The median is the middle point of the data, and I'll tell you, the median is between 25 and 30 somewhere, and we can't figure that out, and let's talk about why. So if you remember how to find a median, you would list the numbers. For example, 1, 2, 3, 4, 5. You'd cross off the highest and the lowest until you found the true center, which would be 3 in this example that I just gave. Now we can do that in our example here. You could cross off points and find the median. Okay. So what I'm doing is crossing off one on the highest and one on the lowest. It's harder here because it's a dot plot. Okay, we won't usually have to do this, but it is a good skill to have and be able to find the median there. So the reason I say somewhere between 25 and 30 is because you would take the average of these numbers, which they should be the same number, so it would just be that number, but I don't actually know what that is. Okay. Median is a measure of center. So that's one way we can measure center. Again, we'll talk about that more later, kind of the logistics. For now, we just want to get the gist of these four things. Okay. For spread, a good word that you could use is range. If you remember range from before, you take the highest minus the lowest. The range of that example is 4. Now, I don't actually know the numbers, but I'll tell you what they are because I have more information. This one's 18 and this one's 47. So if we were to find the true range, I want you to be careful. The range is not 18 to 47. The range is 47 minus 18, which is 29. So when we're talking about range, it is a true number. Again, don't worry so much about the little details of this, but the main idea is that when you are asked to describe a graph, the question's never going to say, describe the shape, center, spread, and unusual features of the graph. It's just going to say describe. And these are the 4 things that you're going to need to pull out of the graph. Okay, we'll talk again more. We're going to talk about shape next. We're going to really dive into shape. We'll talk about spread and after that, and then we'll talk about center. And when we get to center and spread, we can start to talk about unusual features as well. Okay? That's the end of that video, and I'll see you guys next time.